Good day everyone. Allow me to introduce myself. I am John Mark Martinez from BSCS 4B, and today I will be discussing about the completely fair scheduler. So what is completely fair scheduler? CFS is quite simple algorithm for the process scheduling, and it is implemented using red block trees and not queues. So all the processes which are on main memory are inserted into red block trees, and whenever a new process comes, it is inserted into the tree. The main idea behind the CFS is to maintain balance in providing processor time to task. This means processes should be given a fair amount of the processor. When the time for tasks is out of balance, meaning that one or more tasks are not given a fair amount of time relative to others, then those out of balance tasks should be given time to execute. RB trees. A red block tree is a binary search tree, which means that for each node, the left subtree only contains keys less than the node's key, and the right subtree contains keys greater than or equal to it. A red block tree has further restrictions which guarantee that the longest root leaf path is at most twice as long as the shortest root leaf path. This bound on the height makes an red block trees more efficient than normal BSTs. The CFS tree. The key for each node is the V runtime of the corresponding task. To pick the next task to run, simply take the leftmost node. Priorities and CFS. CFS doesn't use priorities directly, but instead uses them as a decay factor for the time a task is permitted to execute. Lower priority tasks have higher factors of decay, where higher priority tasks have lower factors of delay. This means that the time a task is permitted to execute dissipates more quickly for a lower priority task than for a higher priority task. That's an elegant solution to avoid maintaining run queues per priority. Is completely fair scheduler primitive? So if CFS tries to minimize context switches given their overhead, time spent on a context switch is time unavailable for other tasks. Accordingly, once a task gets the processor, it runs for its entire weighted 1 over n slice before being preempted in favor of some other tasks. So going further, if there is one constant with Linux, it's the change is inevitable. Today the CFS is the 2.6 Linux scheduler, but tomorrow it could be another new scheduler or a suite of a scheduler that can be statically or dynamically invoked. There's also a certain amount of mystery in the process behind the CFS, RSDL, and kernel inclusion. But thanks to both Colivas and Molinar's work, we have a new level of fairness in 2.6 task scheduling.